Hello and welcome to this clip looking at a redox and acids first year A-level exam question. As well as a quick walkthrough, I want to go through some of the skills needed to cope with a question like this and how you might develop those skills using your revision techniques. So the skills and knowledge this question requires: recall and application of oxidation number rules, recall and application of typical acid-base metal reactions, writing balanced equations, recall of ion charges, and recall of A-level definition of the term salt. So the oxidation number rules are here, and you'll find them in any decent A-level textbook. If you need to pause and make a flashcard of these, if you haven't done so already, it might be worth just hitting the pause button, going and doing that, and coming back and resuming. So now assumed you might have done that, let's now look at the next thing you need to remember: typical acids and bases. And again, make a flashcard of this if you haven't done so already, by pausing the clip and then coming back to it after you've made that flashcard. Okay, assuming you've got a flashcard on these, the typical acid reactions you need to be able to know and then apply would be these ones. So if they name the acids or metals or carbonates, oxides or hydroxides in the question, you'd be expected to take these word equations and construct the appropriate balanced equations from your own knowledge. And you guessed it, you need to pause and make a flashcard of this if you haven't done so already. So again, hit the pause button if you need to, and come back in a few minutes when you've made a flashcard. So let's look at the question and just take you through it step by step. It says using oxidation numbers. So the first thing you need to do is apply the oxidation number rules to everything in the equation. Now, thinking about which element has been oxidized and which has been reduced, you can identify those as aluminium and hydrogen. So looking at what happens to the oxidation numbers, if it goes up, it's an oxidation. If the oxidation number goes down, it's a reduction. So that gives us aluminium being oxidized from 0 to +3, and hydrogen being reduced from +1 to 0. The next question is a bit more applied. Quite a lot going on here. So let's take it apart as we go. So it behaves as a typical metal, cerium, and you need to recall that particular equation, acid plus metal, giving you salt plus hydrogen. So obviously hydrogen is the second product, because it already tells you that cerium 3 sulfate has been formed. So remembering that sulfuric acid is H2SO4, the cerium 3 sulfate, first of all, means that cerium has an oxidation number of +3, and therefore will form Ce3+ ions. Recalling that the sulfate ion has a charge of -2, and that the lowest common multiple between +3 and -2 is 6, so cerium 3+ is multiplied twice, and sulfate is multiplied 3 times. That'll give us Ce2SO4 3. So the next thing to think about is what has happened to the cerium in this reaction in terms of the number of electrons transferred. So going back to our oil rig idea, oxidation is loss, reduction is gain. Cerium is a metal, uncombined, oxidation number 0. This oxidation number has gone up to 3 + 3, so it's been oxidized. So therefore it's lost 3 electrons. Thinking about a salt in terms of A-level, it's formed from the hydrogen in acid replaced by a positive metal ion, or an H4+. So you can say 2 hydrogen ions in H2SO4 have been replaced by 2 Ce3+. Balanced equation, including state symbols, using the original word equation to guide you, gives you something like this. Okay, having a quick check of the mark scheme against our answers, you can see we've got the first 2 marks, and our answers for the second part, we've got all those marks there as well. So first of all, training yourself, recall work, making the flashcards, use the look, cover, write, check, repeat technique, repeating it as many times as you need to, getting your friends and family to test you out. And the application work is using the 3-pen method on exam questions. Black is no help, blue is going back over it, and red is using the mark scheme. Thanks for listening, and until next time, see you soon.